people at home, we're still on worksheet 2-3. On your unit circle, on the back of your unit circle, you might want to jot this down, okay? Some notes on the back of your unit circle, okay? The one that has all the right answers on it, not like the one that Chloe has wrong answers on it. That's crumpled up. Am I being a simp right now?
No.
No? Okay. All right, so you might want to jot this down. We said from day 2, the second day of school, we talked about unit circle on day 2, that the unit circle is a circle with center 0, 0 and radius of 1. So, I mean, if I give you this, don't write this down. If I give you x minus 3 squared plus y plus 4 squared equals 100, for example, the center of that circle would be, if you guys remember, 3, negative 4, and the radius would have been 10. You guys remember how we did that? Where did 3, negative 4 come from? 3 was what? Opposite. Where'd 10 come from? Square root. Opposite, square root, okay? Well, if this unit circle is 0, has a center of 0, 0, it would be x minus 0 or x plus 0, either way. So I'll put that in there. Y plus 0 or y minus 0, doesn't really matter, equals 1 squared, which is 1. I can clean this up here. X minus 0 is just x squared plus y plus 0 is y squared equals 1. So if I ask you to graph x squared plus y squared equals 1, that's a unit circle, okay? But at the top of your unit circle, we have something down there for x. It says x is the cosine value and y is the sine value. So just watch for a second here. That's the same as cosine squared plus y squared, not y squared, sine squared equals 1. Now, normally, and there's nothing wrong with that. There's absolutely nothing wrong with writing that down. But for example, just listen carefully. Hopefully, when you listen, you'll be like, huh? An equation of a line, true or false? An equation of a line is mx plus b equals y. Really? Mx plus b equals y? That's not an equation of a line?
It is.
Well, why'd you guys kind of say no at first? And that was
Because you put
don't you normally say y equals mx plus b?
B.
Instead of mx plus b equals y? I mean, it's not wrong. It's just not the way you say it, okay? Or how about this? The Pythagorean theorem. True or false? The Pythagorean theorem is b squared plus a squared equals c squared. Yeah, but you don't say b squared plus a squared. You say a squared plus b squared. Same thing with this. You don't normally say cosine squared plus sine squared. You say sine squared plus cosine squared equals 1. Now, there's nothing wrong with that, okay? But that, again, that doesn't really make sense because, for example, you guys got your unit circles out. What's the cosine?
Of what?
Very good. Of what? It doesn't make sense to say just what's the cosine. It doesn't make sense, okay? So this is something very basic, but also very, very, very important, okay? I want to make sure our terminology is all on the right page here. What we should say here is this. Don't write this down either yet. I mean, what we've done, just want to make sure what we got from this, is we came up with our equation of our unit circle, x squared plus y squared is 1. Then I plugged in x is the same as cosine, y is the same as sine. And then I reversed them because addition is commutative. Remember, you can switch the order around. What we should do, and don't write this down either, is the sine of some angle squared plus the cosine of the same angle squared equals 1. Now, I told you not to write that down because that's not the way you normally write it, okay? Again, another example is this. I'm going to put somebody on the spot right here. Zach, what is x times 2? What's x times 2?
I don't know what x is.
I know, but what is that? Can you simplify x times 2?
X squared?
Careful, x times 2, I said.
No, it's 2x.
2x. Now, why didn't you say x2? Because
Now you say
that's not the way. You just don't say it that way. I mean, you initially said x squared, then you caught yourself. You don't say x2, you just say 2x, okay? What this is saying here is whatever the angle is, you would take the sine of it and then square it. Here, whatever the angle is, you take the cosine and then square it. That's not the way you write it, though, okay? You write it like this. Sine squared theta plus cosine squared of theta equals 1. This is the same as this, okay? So what I mean is this. I want to be very clear on this. If I ask you the sine of 30 degrees, okay, the sine of 30 degrees, you look it up, you say a half, okay? If I did this is saying sine of 30 degrees is a half. This is saying take that half and square it, and you get 1/4, okay? If I did this, that's saying the same thing, and that's the way they normally write it, okay? When it says sine squared of 30 degrees, it's kind of weird here, but sine squared of 30 degrees says take the sine of 30 degrees and then square it. and you write it like that, because if I write it like this, do you think that means the same thing?
No.
What do you think that's telling you to do first?
Sine of
Mm-mm.
Square 30 and then get the sign.
Square 30, and then, which is 900, and then take the sine of that, okay? So, just so you understand, I want to be very clear, and it's a little bit tricky the way it's written. If I gave you, for example, this right here, what are they asking you to do there?
Find
What?
the
Cosine of 20, what? And then square it, okay? That's the same thing as this right here. If I get rid of the parentheses, does it change it?
Yeah.
Yes, it does. This is saying do what first?
Square.
Square 20, and then cosine that, okay? So, here's what you need to jot down. This is one that you really need to memorize over the next few days or so, okay? Is this one right here. Sine squared of theta, and put that on your unit circle somewhere, on the back of your unit circle. Sine squared of theta plus cosine squared of theta equals 1, okay? Sine squared plus cosine, and I'll say sine squared plus cosine squared is 1. I really should say sine squared of theta plus cosine squared of theta equals 1, okay? All right. Now, something that Jonathan actually brought up yesterday, he went a little further with it, we're not gonna today though, is if I was to give you this, if you remember that when I taught you the unit circle, on the unit circle, when I had 30 degrees and when I had 60 degrees, this one was radical 3 over 2 1/2, and this one was 1/2 radical 3 over 2. We said that you switch the cosine and the sine when you have 30 and 60, okay? Now, I have no idea what 10 degrees is, okay? But when I'm at 80 degrees, what I want you to understand is the cosine here will be the same as the sine here. And the cosine here is the same as the sine here, okay? So as long as the, and I'm not gonna prove it right now, we'll do that eventually later in this course in a few months or so. But what you need to understand is cosine and sine are the same as long as, what's so special about 30 and 60 and 10 and 80? They're not the same angle, but what?
They add to 90.
They add to 90. You guys remember what those are called? You learned it in geometry. Two angles that add up to 90? Well, they add up to a right angle, but what are the two angles called if they add up to 90? 180 are supplements. 90 are,
Do they start with a C?
yes it does.
Congruent?
Not complementary, complements, yeah. In complements, not like, hey, good job, you know, not that. But, you know, complementary means they add up to 90. So, what I want you to understand is this. Let's see, how do I want you to write this? Jot this down on the back of your unit circle. Sine and cosine of complementary angles are the same. The sine and cosine, and there are other things we could do off that, and that's what Jonathan was asking yesterday about tangent. Don't worry about that right now, okay? The sine and the cosine of complementary angles are the same. So what that means is this. Actually, jot that down, then I'll tell you. Is there anything else we have to do on this? No. Okay? So if I give you this, the sine of 40 degrees, I have no idea what the sine of 40 degrees is, but it's the same as the cosine of 50. And the reason is, 40 and 50 are complementary because they add up to 90, so the sine of 40, whatever that is the same as the cosine of 50. How about this? What would the cosine of 89 degrees be the same as?
The sine of 1 degree.
The sine of 1 degree. Okay? Now let me ask you this. Is the sine of 20 degrees equal to the cosine of 20 degrees?
No.
No. I thought sine equals cosine. As long as the angles add up to 90 are complementary. So I'd have to say sine of 20 equals the cosine of what? 70. Okay? How about this? The sine of 55 equals the sine of 35. Yes or no? Sine of 55 equals sine of 35. No, why? They're complementary. They're both sine. I'd have to do what to make that a true statement?
Make one for.
Make which one cosine? Either one. It wouldn't matter which one, okay? So, as long as they're sine and cosine and the two angles add up to 90, they're the same, okay? I'm gonna keep using his brothers, his youngest brothers for an example. You know, I know they're twins, I know they're the same age. I know they're exactly the same age, okay? Don't say a couple minutes older or whatever. They're the same age, okay? So, all right, so those are the two things we need to know in order to do the rest of this worksheet, okay? I like these last few questions, but in years past, some students really struggle with these, so we'll see how things go. We're only going as far as number 87 today. 88 will be the last one you guys are doing now. Okay, so number 77. Okay, now here's the deal. Also, I should have said that. I said it, but I said it very quickly. I want to be very clear here, okay? Sine squared of theta plus cosine squared of theta equals 1. Listen, I'm going to be very, very picky on this, okay? What does theta represent? An angle. Now here's where I'm going to be picky, okay? What's the theta here represent?
The complement?
No, not the complement. Tell you what, let's do this. Put this on hold. Forget this. How much money's in my right pocket? You have no idea. So you'll say I have what?
$2.
You know it's $2?
No.
So what are we going to say it is?
What's that gonna get?
X dollars, okay? How much is in my left pocket?
That gone up.
Is it X dollars? Should you say X dollars? Why shouldn't you say X dollars?
Because you already said that.
'Cause that's assuming what? If there's X here, you say there's X here, you're making the assumption,
That's the same.
and is there the same amount? You don't know. It might be, but you're going to assume it's not, okay? So, this is X, this will say this is Y, okay? You can't say they're both X. So, if this right here's theta, you said that's an angle. What's this right here mean? It's the
Why?
the same angle. It's got to be the same angle because that's the same theta, okay? So, be very careful here. If I gave you sine squared of 17 degrees, I have no idea what the sine squared of 17 degrees is. No idea, okay? Plus the cosine squared of 17 degrees, I have no idea what that is either. But you know what you get? 1. You get 1. As long as the angle's the same. This right here, sine squared of 38 degrees plus the cosine squared of 38 degrees is 1. On your first test, there's going to be a question like that. Is there going to be a bunch of them like that? No. There'll be like one question. One question, and the answer is 1, okay? How about this? Sine squared of 42 degrees plus the cosine squared of 47 degrees. What's that equal to? That's a really good answer, actually.
You tell me.
Nobody's got it? You answered in 2 words. Okay, yeah, I don't know either, but I can tell you something. No? You're thinking too hard. Okay, what? It's not 1. Why? Same angle. I don't know what it is. It's not 1. It's not 1 because the angles are not the same. Very good. That's what I was looking for. I don't know what it is, but it's not 1 because the angles are different. Okay? All right. So as long as the angles are the same, the sine squared plus cosine squared equals 1. So let's look at number 77. So we have, I'm going to write this down. Sine squared of 40 degrees plus cosine squared of 40 degrees.
1.
1. Write it down. Now, listen carefully. On these problems, what you want to do is make the angles the same everywhere. We didn't worry about that at number 77 because the angles are the same, okay? So we look at number 79. It says sine 80 degrees, and then it says cosecant 80 degrees. That's not 2 questions. That's 1 question, okay? They're not asking what's the sine of 80 degrees and the cosecant of 80 degrees. There's no symbol in between them. So it means the sine of 80 degrees what? Times the cosecant of 80 degrees. Now, I just told you a minute ago, make the angles the same. They are, okay? They are the same, okay? So, I'm going to take this really slowly here, something I have not shown you yet. I have, but not explicitly shown you this, okay? I don't like cosecant. I just don't like it. I like sines and cosines and tangents. That's the first thing I taught you guys was sines, cosines, and tangents. Those are easier to work with than cotangents, secants, and cosecants. So here's what we want to do. We want the angles to be the same, and we want the trig functions to be similar, okay? Watch really carefully, okay? Because this goes kind of, I'm going to go slowly, but even going slowly, it goes kind of quick right here, okay? Could somebody describe to me in words, what is cosecant?
Opposite.
Don't say opposite. Okay, inverse, I use the word, inverse is okay, but I like the word reciprocal of what? Sine. Watch carefully. It's the, I'm going to write this down. Cosecant is a reciprocal of sine. That's what you guys just
What's the
said.
difference of reciprocal and inverse?
Well, I would say multiplicative inverses. Okay, that's what reciprocal is. Inverse functions, those are different. That's something that's different. Okay,
Oh.
it's kind of like if we talk about range in mathematics, range could mean the biggest number take away the smallest number. It also could mean the y values that are used. There's one word that can mean more than one thing. Okay, so I'll just be careful on that. I mean, if you say reciprocal, that knocks it out. But if you just say inverse, you really need to say multiplicative inverses. Okay, so you said cosecant is the reciprocal of sine. Let's just keep watching on this, okay? So if I just did this, sine, let's make sine into a fraction. How do you make anything a fraction? Don't think hard on this. How do you make anything into a fraction? Put on 100, okay? So cosecant is the reciprocal of sine over 1, okay? Don't look at this right here, okay? Flip sine over 1. 1 over sine. So cosecant is the same as 1 over sine. It's the same thing, okay? Do you see that? If we have sine, if I just said sine, you guys said, that looks terrible. You guys said sine is or cosine is a reciprocal, cosecant is a reciprocal of sine, okay? If I said sine is sine over 1, I say flip that, you'd have 1 over sine. And if you flip sine, you have cosecant. So, what is another way of saying, here's what we're going to do. On the back of your unit circle, I would put this down. Put down cosecant is the same as 1 over sine. It's the same thing. That's a mathematical way of saying that cosecant is a reciprocal of sine. I'm going to say it another way, okay? Did I say reciprocal? Not reciprocal, the same as. I'm sorry. Another way of saying it is this. If cosecant was a fraction, it'd be cosecant over 1. Let's think of it this way. Cosecant over 1 means cosecant's on top. Cosecant on top is the same as what where? Sine on the bottom. Cosecant on top is the same as sine on bottom, okay? We're going to jot down what secant is. What do you think we're going to put down for secant? Secant is the reciprocal of what? Cosine. Flip cosine over 1. 1 over cosine. And I didn't put these on here, but we really should have what's after all these trig functions, thetas. But if you don't, it's okay. What is cotangent? The reciprocal of tangent. So 1 over tangent. We're going to put one more thing. On the back of your unit circle, you should have put down that tangent is sine over cosine. So what else is cotangent? And cotangent is, tangent is sine over cosine.
Cosine over sine.
Right, what'd you do? Flip it. How do you find cotangent? Flip tangent. What is tangent? Sine over cosine. Flip sine over cosine.
Cosine over sine.
Cosine over sine. Jot these down on the back of your unit circle. Important stuff. I'm curious, those guys that went to the Math Science Center, the 2 of you in here, did you guys ever do trig identities?
I don't even know what that is.
You don't even know what that is? Okay, trig identities? You're gonna like, I have a feeling you're really gonna like them.
Maybe, but
No,
I
you
might
would
not
know.
The name of it.
You would know. It's where they give you have to prove something's true. Trig identities, they give you one thing and they have to prove that something else is true. It's all about showing your work.
That kind of sounds familiar, actually.
Okay. I think you're gonna like, just from knowing you for 3 or 4 weeks, 5 weeks, whatever it's been, I just have a feeling that you're gonna like it.
I mean, we did a lot of proof things are true. That's pretty much their entire teaching.
Okay. Well, it's a different kind of proof, different than geometry proofs. But students either love it or hate it, okay? But anyhow, so let's look at this. Why did I bring all this stuff up here? Well, our angles are the same, that's cool, but we'd like them to be similar. And I like sines, okay? So instead of saying cosecant 80, that's the same as what? What is cosecant the same as?
1 over sine.
So, 1 over sine 80. Cosecant is the same as 1 over sine. Not only are our angles the same, everything's in the form of sine. Now what? And you know this. You guys learned this a few years ago. Now what do we do? Huh?
No, that's divine.
Yeah, it's all, if it was divide, you flip and multiply, but it's already multiplied.
Multiply top
What's the
by
answer?
top.
The answer's 1. See you later. 1. They can't. What's the sine of 80? You're up, Meerkat. What's the sine of 80? I don't know either. I have no idea. I don't know how old his brothers are, his younger brothers are. But I know when I subtract their ages, you know what you get? 0. Because they're the same. I have no idea what their ages are. They're probably 13, maybe 14, I don't know. But I know when I subtract them,
Because on that.
you're going to get 0. Because they're twins. 81. Okay, tangent of 10 times cotangent of 10. No, that's 80. 81. Tangent of 40 minus what? Sine 40, cosine 40. Okay. All we're doing is this. We're trying to simplify expressions without using a calculator because you don't need a calculator. Just like if I ask you the sine of 30, you shouldn't need a calculator for that because it's on, well, on people that got a good unit circle, they have the right answer on it. So, any idea what we should do? There's more than one way you could do this one. I mean, our angles, we like our angles or not?
Yeah.
Yeah, why?
They're all the same.
They're all the same. Is the unit circle going to help you on this one? No, you don't see 40 degrees written on there. Okay. Okay, so we have all the angles the same. That's good. Okay. Is that still going, I hope? What's that? I'm glad you said that. And I've already kind of addressed this today in another situation. He said sine over cosine's tangent. As long as the angles, what? Have to be, and are they? Which they are. Yeah, so I just want to make sure we understand that. I've been saying tangent sine over cosine. I should be saying tangent sine over cosine as long as the angles are the same. Okay, and they are. So can I rewrite?
40 minus tangent of 40. 0.
0. This is tangent because the angles are the same. So the tangent of 40 minus the tangent of 40. I have no idea what the tangent of 40 is. But when I subtract something from itself, it's 0. Just like I'm not sure exactly how old Cal and Max Bigelow are, but I know when I subtract them, you get 0 for an answer.
You really like talking about your brothers.
What's that?
You really like talking about his brothers.
Brothers, I tell you what. I remember they came over to our house once. This is like, we were still living in Battle Creek. This is like 6, 7 years or so ago. Man, they were some busy boys, I tell you what. They went into our garage, and I think they took every single thing that was in the garage out of the garage and were just playing with it all over. They were very, very busy kids, I tell you.
Yeah, that sounds like it.
And they were like, and it's not a big deal, but it's like, and there we had like a sandbox, and they were playing the sandbox, and they're like just taking it and just like dumping it into the yard. It was like no big deal. It's like, what are you doing, man? I mean, they were just, it wasn't an accident. They're just like scooping, swoop, and they're just doing it to do it. So,
Okay, we can answer that one real quick.
yeah.
So,
Okay, 83. Okay, so we have cosine 400 and the secant of 40 times the secant of 40 degrees. Okay. So, we like those angles? No, why? They're not the same. Let's make them the same. This goes. We haven't talked about this today. We talked about, yeah, I think it was yesterday. What can we do to make the angles the same? Yeah, okay, but how do I want to say this? You can't change the value of it, okay? I mean, what I mean is this. I mean, it's like saying, you know, I want to have twice as much money, so I'm just going to times by 2, and I got twice as much money, okay? I didn't just get richer, okay? You can't do that, okay? And I do want them the same, and yes, if we divide by 10, it will be 40. I totally agree with that, but you can't just take an angle and divide by 10. You can do something at 400, though. You can't divide by 10, but you can do something to it. And it will change the value of the angle, but it will not change the cosine of the angle. Not square rooted. Let me ask you this. On your unit circle, let me ask you this. How would you guys find the sine of 390 degrees?
A full unit circle is 360, and that's full.
What happens when you go all the way around the unit circle? It starts over again. It all repeats. Remember the cycle? The period of cosine is all the way around. Sine, it's all the way around. Is tangent all the way around? You only have to go how far? Halfway. Then it starts repeating, okay? So you guys said divide by 10. We shouldn't divide by 10. We should do it. We should do what though? Not by dividing. Yeah. Yeah, you do. It's just you're thinking too hard.
Simplifying the angle or something?
How'd you get to 40? What'd you do?
I went around 1 and then added
When you go around 1, what's that?
360.
360. So what do you do with 400 to get 40?
Subtract 360.
Can you subtract or add 360? Sure you can. You're not allowed to divide by 10, but why are you allowed to add 360 or subtract 360? I just told you. Because every time you go 360 degrees, what?
Same.
It starts over, okay? What day of the week is it 28 days from now? It's a,
Friday.
definitely a Friday. Every multiple of 7, we're back to the same day. You're allowed to subtract off 360 degrees. Or we could have done what to 400? Added on 360 degrees. Okay? Now again, is it the same angle? No, but the cosine of the angle is going to be the same because you end up in the same spot. So we have the cosine of 40 degrees times the secant of 40 degrees.
And secant is just 1 over cosine, so.
So cosine of 40 times 1 over cosine of 40. What's the answer?
1.
Why?
Because if you times something by, I don't know actually, Brayton said it was.
Here's what he said. Cross them off. They cancel. I think he actually did that. I think I saw Brayton go like that. He didn't even say anything. I think he just said slash them off. So the answer's 1. Now what's a cosine of 40? Anybody know it? I don't know what it is. Okay. Is it negative or positive? Cosine of 40. Why positive? One word.
It's in the.
One word. I only get to say one word why cosine's positive when it's 40.
Right.
Good. It's positive something. Could it be positive, could it be positive 0.7, perhaps? Could it be? Perhaps? Yep, could it be positive 1.3? Listen carefully to this one. Could it be positive 1.3? He said it could possibly be positive 0.7. Could be positive 1.3. What's the biggest cosine ever gets to? 1. What's the smallest it ever gets to? Negative 1. What's the biggest sine ever gets to? It's a unit circle. The biggest it gets is 1. So I don't know what that is, the cosine of 40, but it can't be over 1. Okay? All right. That was number 83. Let's look at 85. 2 more to go. Okay, so here's what we're gonna do. Okay? You guys don't like radians, do you? Do you guys like radians or do you like degrees better? I think most of you guys probably like degrees better. So here's what we're going to do. For some practice, negative pi over 12. You guys remember how to make that into degrees?
Multiply it by 180 over x.
Not over x.
Or pi.
Now, I think I told you guys this. A lot of students, if you look at the back of your sheet, it says convert from degrees to radians or radians to degrees. One of them says times by pi over 180. The one says times by 180 over pi.
So you
This
want-
doesn't always work, but do you think, and don't look at the back of your unit circle, do you think that's the way you're supposed to do it? Times?
No,
Why?
cancel out.
What would cancel? The
Yeah.
pi's cancel?
No.
No. But if you do this, then the pi's will cancel. That doesn't always work, okay? It doesn't always work, but most of the time it does. So, these pi's cancel, so we're left with negative 180 over 12, and that actually divides out to negative 15 degrees. Okay, so we have the sine of negative 15 degrees. Again, I want to make sure we understand, why are we making these into degrees?
It's easy.
Most students think it's easier to deal with degrees than it is radians, okay? And then the cosecant of 25 pi over 12. Let's make that into degrees. So times by 180 over pi. What cancels? Pi's. A really nice one to know in this class is 12 goes to 180 15 times. You don't have to memorize that, but that's a really nice one to know. Okay? And then we take 25 times 15, which is, what is that? 375. Okay, you guys have the opportunity to really impress me here in a minute. So we have the sine of negative 15 times the cosecant of 375. I'd like the angles to be the same, and they're not. So what could I do? I'd like to make the angles smaller. I don't really want to make it bigger. So what can I do with that 375?
I'll go around again.
So what does that mean? Subtract 360. Because what's the period of cosecant? 360 all the way around, okay? So we minus 360. So we do that, we have the sine of negative 15 degrees times the cosecant of 15 degrees. Here's where you have the opportunity to impress me.
And sine is odd, so you can't.
He's got it.
Same thing.
Slow down, slow down, slow down. He's on it though, okay? This right here, that looks terrible. Cosecant of 15 degrees. My angles are not the same. They're not the same, okay? But could I change this? Could I just make, if that was 15, the angles would be the same. So Jonathan, is the sine of negative 15, can I just make the sine of 15, is that okay?
No,
Why?
because they're odd.
What's odd?
Sine's odd.
Sine's an odd function. So there's a relationship, they're not the same, they're what?
They're, I would say, opposite.
Yeah, not just you, they are opposites.
No, I was trying to say
Yep.
inverse, I'm like, no,
Yeah.
no, no.
Yep, they're opposites. So how do I make opposites the same? What do I stick in front of this? Negative sign. Why did we just do what we did? What do we see now? The angles. What? Look at them.
They're not the same.
They're the same. They're the same angle. Now what's the sine of 15 degrees? What'd you just say, Meerkat? I don't know either. I have no idea what it is. No idea.
We know
Okay?
that.
But, again, what we did here was this. Let's backtrack here. I subtracted 360 because the period of cosecant 360 to get to 15. Now, did we get the exact same angles? One was 15, one was negative 15. We're closer, but we weren't there. Then I said, let's just make that into positive 15. Jonathan said, nuh-uh, you can't do that. It's an odd function. You don't get the same thing, you get the opposite. So we'll make it the opposite into the same by putting a negative in front of it. Now my angles are the same. What's the next thing we're going to do?
We're gonna change cosecant into 1 over sine.
So sine of 15 degrees, be careful at the end here, times 1 over the sine of 15 degrees.
Negative sine of
Okay? Cross stuff off, what are we left with?
negative 1.
Negative 1. Don't forget that. You're going to cross these off, but you're not left with 1. You're left with negative 1. That's a tougher one. That is definitely a tougher one. Okay? Now, if you're sitting there going, man, these are tough. I don't hope there are going to be questions like this on our test. There'd be one or two. There's going to be a question like number 77. Did you guys show your work on number 77? Why?
Because it was.
That's the easiest one of all. I just give you the answer. Okay? That's the one where sine squared plus cosine squared is 1. Okay, there'll be a question like that. Okay, let's try number 87. Last one. Sine of negative 20 degrees over the cosine of 380 degrees plus the tangent of 200. Okay. So we got 3 different angles and 3 different trig functions. So let's deal with the angles first, okay? And we may not get the same angles right away, but we'll get close. Like right here, we went from 375 to 15. They weren't the same, but they were closer, okay? So any idea what you could do with negative 20, 380, and 200? I mean, to get them all at least closer and then eventually get them to be the same?
Subtract 360
From what?
from cosines.
Because 380, because the period of cosine is 360. You go all the way around, and you're back where you started. So if I subtract 360, we have the sine of negative 20 over the cosine of positive 20. Are they the same? No, but they're opposites, and we'll get there.
Subtract 180 from tangent, bring it down.
Why 180?
Because tangent only needs half a rotation.
You don't have to go all the way around for tangent. Remember? It repeats once you get halfway around, tangent starts repeating itself. So you don't have to subtract 360, subtract 180. And why would you rather subtract 180 instead of 360? I mean, could you have subtracted 360?
It drops it down to 20.
Right. You could have subtracted 360, but then you'd be at negative 160. You don't want that. Tangent of 20. Okay. Now our angles aren't all the same, but they're closer. There's one more we still have to change. Actually, time out. Can I just go ahead and sine over cosine's tangent? Can I just do that or not?
No, because the angles are
The angles are not the same. Yes, sir.
Can you put a negative sign in front of the sign to make the?
Tell me what to write. Negative sine what? Negative 20?
Sine of 20 degrees.
Okay. So what Bigelow's saying is this. We'd really like this negative 20 degrees to be positive 20. So, Lou, is the sine, and Jonathan already answered this on the last question, is the sine of negative 20 the same as the sine of positive 20? That's okay, that's a legitimate question. Why are you saying no there, Meerkat? You're right, they're not the same. Sine's an odd function. It's not the same, they're what? Opposites. How do you make opposites the same? Put a negative in front of it. It's no different. If you're wondering, how can you just do that? What I'm doing is this. It's no different than this easy question. Is that a true statement? No? You know how I can make it true? Now it's true. Or I could have done this. Now is it true? Yeah, because negative 5 is 5. Okay? So, we just said a second ago, these are not the same. They're opposites. So, how do I make opposites the same? Put a negative in front of it.
And now wouldn't that be negative tangent 20 and a negative
Right.
positive?
Sine over cosine. We can do that now?
Yeah.
We couldn't before. Why can we now?
Because they want the same.
Now they're the same angle. So we have what? Sine 20 over cosine 20 is what? But it's not tangent of 20, it's
Negative.
negative tangent of 20. Anybody know that a tangent of 20?
No, but we don't need.
We don't need to.
Because negative tangent 20 is.
And positive tangent of 20,
It's opposite.
Zero.
and when you add opposites,
You get 0.
now if you're sitting there going, shoot, the answer's either 0 or 1 on these, I'm just going to guess. No, you got to show your work on these, okay? So you just put 1 and guess right, except for this one. That's an easy one. You shouldn't show your work on that. We'll get more practice on these on Tuesday, okay?